Now we will start next non-inertial frame, because we have already studied two types of frames, that is inertial and non-inertial. Now we will start second frame, that is non-inertial frame of reference, frames of references. So what is non-inertial frame? We know that there are two different frames. First frame, which is at rest, x-axis, y-axis, z-axis. This frame is at rest. And second frame is moving with variable velocity or constant acceleration. So in this case, this frame is S dash frame, it is y dash, z dash, o dash, and this one is x dash, the second frame. Now first frame is at rest, it is at rest, but this frame is moving with constant acceleration. Constant acceleration means velocity is variable. So it is not uniform, it is non-uniform. So we will study the motion of the particle in both these frames. So let the particle is lying at here, the particle is here, P. The position vector of this particle from first frame is r, and the position vector of the same particle from second frame is r dash, and the distance between O and O dash, this is unknown. So we have to derive the correlation between r and r dash. Okay, means there is single particle, but we are observing the motion of the particle with respect to two frames, S and S dash. So in triangle O O dash P, triangle O O dash P, this is triangle, okay, and O O dash plus O dash P is equal to OP by using triangle law of vector addition. Triangle law of vector addition. What is triangle law? The sum of two vectors which are in the same order is always equal to the third vector which is in the opposite order, that is O O dash plus O dash P is equal to OP. These two vectors are in same order and OP is in the opposite order. Opposite order means it is resultant, it is sum of two vectors. So here, what is O dash? O dash. So it is unknown basically. We have not known this O dash, but O dash P, it is R dash. So O dash plus R dash is R dash, and OP is R vector. Okay, or R dash is equal to R minus O dash. This one is O dash. So what is this O dash? So we can calculate, we can find the distance O dash by using the concept of uniform acceleration motion. We know that before some time this S dash is lying at here, and because it is moving, so after t time it is reaching at this point. So the motion of this S dash frame from O to O dash is uniform accelerated motion. So therefore applying the formula for uniform accelerated formula. What is this formula? So we have studied these formulae, 4 formulae in +1 class. So I am using the formula S is equal to ut plus half at square. You know that this is formula for uniform accelerated motion. So here S is distance. So what is distance? Distance is O dash, because the distance is this. So I am applying this formula for these 2 points, because it is 2-point formula. So 2 points are O and O dash. O and O dash, these are 2 points. So O dash distance is O dash, and ut, what is U? You know that when there is constant acceleration, it means the velocity before some time velocity is 0. So initial velocity is 0. It is 0. Initial velocity is 0 and half a. So let the acceleration of this frame is a naught. So I am taking the acceleration of frame is a naught, a0, because a and a dash, these can be reserved for motion of the particle, but the motion of the frame is noted by a naught, or acceleration of the frame is noted by a naught. So in some books it is written by capital A or a naught, and so many symbols can be used for motion of the frame. So I am using here a naught into t square. The time taken from this time to this O to O dash is t. So this is value of O dash sorry. So O dash is equal to half a naught and t square. So putting this value here. So R dash is equal to R minus this half a naught vector t square, because a naught is vector quantity. So this is the equation for displacement or position vector of a particle with respect to two frames, S and S dash frame. Here S dash frame is moving, but S is at rest. So if you observe deeply, then this S frame is inertial because it is at rest. Inertia, it follows the law of inertia, but it is moving with constant acceleration. It is non-inertial. So this is the interrelation between two parameters. So it may be written as x dash is equal to x, because we can split R into different three components, x, y, z. So x dash is equal to x minus half a naught t square. Okay. So this is combined equation for x, y, z. Now the relation for velocity. So this is position or displacement. Now velocity, we know that velocity is the rate of change of displacement or position vector. So we can find the formula for velocity by taking derivative this equation number 1 with respect to time, because velocity is a rate of change of displacement with respect to time. So taking derivative, differentiating equation number 1 with respect to t, time t. So it will become dr dash upon dt is equal to dr upon dt and minus ddt of half a naught t square. Okay. So dr dash upon dt, it is u dash, velocity u, because velocity of particle. Dr upon dt is u. It is velocity of particle in S frame, it is velocity of particle in S dash frame. This particle is moving and velocities are u and u dash. Okay. And minus derivative half constant, a naught is also constant. Why a naught constant? Because this frame has constant acceleration. So constant term come out from the bracket, it independent of this time. Therefore derivative of t square is 2t. So 2 is cancelled. So it is u dash is equal to u minus a naught t. Okay. So this is Galilean transformation equation for velocity in non-inertial frame. The inertial frame is this, in which one frame is moving translational motion with constant acceleration. Okay. Velocity. Now you will find acceleration. So what is acceleration? Third one. So you know that acceleration is the rate of change of velocity. So we will derivative or differentiating number 2 equation with respect to t, on both sides. So it will become du dash upon dt. I am taking derivative. It is du upon t minus d dt of a naught t. Okay. Now du dash upon dt, it is a dash. What is this? This is acceleration of the particle in S dash frame, a dash. And du upon dt, it is a. it is again acceleration of the particle but in S frame, and minus this A naught is again constant because A naught is the acceleration of frame and it is constant, and dt upon dt is 1. Okay. Therefore, this is the equation for acceleration. So, what is A dash? It is acceleration of particle in S dash frame. It is also acceleration of particle in S frame, and A naught is acceleration of frame. It is acceleration of frame. So, this is equation for acceleration of the particle as well as frame. So, in this case, in all cases, in case of r dash is equal to r minus half A naught t square. So, we have proved these three equations. In all equations, r dash is not equal to r because there is subtracted some term from there r. Therefore, r dash is not equal to r. It means it is Galilean variance. This equation is Galilean variance, or displacement is Galilean invariance, variance. Sorry. Similarly, u dash is not equal to u because it is obvious that u dash is not equal to u because some term is subtracted from u dash, then it will become u dash. Therefore, it is not equal. It means again Galilean variance. It is also Galilean variance. All terms are varying under Galilean transformation equations. But in previous case, the previous article, we have studied that the displacement and velocities are variance, but acceleration is invariance. But in this case, in the present case, in case of non-inertial frame, the acceleration is also variance. It is also varying. Now, fourth number is force. What is force? We know that force is the product of m and a. Okay. So, multiplying this equation, maybe equation number 3, with mass m on both sides, we will get ma dash equal to ma minus ma naught. So, what is this? This is F dash, force acting on the particle in S dash frame. It is F, force acting on the particle in S frame, minus ma naught. This is force acting by the frame. These forces are of particle, but it is due to frame. So, we may write this minus ma naught means, mind it, minus ma naught, not only ma naught, but minus sign is also there. Minus ma naught is called f naught plus f naught. Sorry. So, I have put this minus ma naught is f naught, and this force is applied by frame, but these forces are of particle. It is force are of and this force is of frame. So, frame force and these are particle forces. So, this force is different than these two forces. So, this force is called fictitious force, where F naught is called fictitious force. Fictitious means pseudo force or pseudo force, arbitrary force, because this force is basically not due to particle, it is due to frame. The frame is applying some force on the particle in indirect method. So, pseudo force or fictitious force. So, minus F A naught, the value of this F naught is minus M A naught, sorry, this force. So, this is called fictitious force or pseudo force or arbitrary force. So, in non-inertial frame, this fictitious force term, this new term is introduced, that is force of fictitious or fictitious force or pseudo force. Now, we will again solve these 5 parameters in second non-inertial frame. So, what is second non-inertial frame? So, we have studied this frame is non-inertial, but now I am not taking this frame as non-inertial. Now, second part of non-inertial frame. Means it is again non-inertial frame, but it is uniform rotating frame, a uniformly rotating frame. The frame which is rotating about a fixed point is also called non-inertial frame. So, we have studied the two examples or two types of non-inertial frames. First frame is linear, but it is moving with the constant acceleration, and second frame is uniformly rotating frame. It has also constant acceleration. This frame has also constant acceleration. So, what is this frame? S frame is fixed. S frame is fixed, that is x axis, y axis, z axis, it is at rest, it is fixed. But the second frame, no, in this case, second frame is rotating. Means this frame is going to this side, it is rotated toward this side, and x is rotated toward this side. It is tilted by some angle. This angle is maybe d omega, small angle is d omega, d omega, d omega. So, this frame S dash, it is y dash, it is z dash, it is x dash, and O dash is also lying here because it is rotating about O point. So, O and O dash are coinciding with each other. So, this second frame is S dash frame, first frame is S frame. So, this frame, these frames, set of frames is also called non-inertial frames of references. So, we will find all 5 articles or 5 parameters for point particle P. Again, particle is lying here. So, we will measure the position of this particle with respect to S frame as well as with respect to S dash frame. So, in this case R dash and R, because OP is here, that is R, and O dash P is also here because O and O dash are coinciding with each other. Therefore, R and R dash both are lying at same line, but the direction of R dash is not equal to R. Means R is equal to R dash in magnitude, okay, but direction is not same. The magnitude are same, but the direction is not same. So, this is the equation for position or displacement. Now, second we will find velocity, acceleration, force, all these parameters in our next lecture. So, this frame, uniformly rotating frame, is very important according to examination point of view. So, thank you very much.